everybody, I have some little notes for you to write down. If you could copy down these triangles. This up here, this is very important for you to know. I'll write this part down again, and I am going to be adding something after the S's and after the C. We know this part so far. This is the tangent ratio, opposite over adjacent. And today we'll be learning the sine ratio and the cosine ratio. So I'll give you a little second to write that down. And so we're going to be looking at, again, looking at ratios from a reference angle. And that's just the angle that we're working from. So for here, triangle ABC, let's look from reference angle A. And we're going to be still just labeling the sides. Oh, how'd that happen? So across from our right angle, it's always the longest side. It's always the hypotenuse. And that doesn't change from whatever angle we're looking from. That's always the hypotenuse. From reference angle A, directly across from that, sitting across from it as a booth, as I say, is the opposite side. And then adjacent to or touching angle A, but not the hypotenuse, is called the adjacent side. Okay, like that. So our sine ratio is the opposite over the hypotenuse. And our cosine is the relationship between the adjacent side and the hypotenuse. So as our tangent is the ratio between the opposite side over the adjacent, our sine is the opposite side over the hypotenuse, and our cosine is the adjacent side over the hypotenuse. So in this triangle, the opposite of sine A would be length, or this side right here, BC, over the hypotenuse side AC. Oh, I hate it when it does that, but what can you do? There we go, over AC. And our cosine is going to be the adjacent side, AB, over the hypotenuse, that's still AC. Okay, and for reference angle C, so if we're over here, it's still the opposite over the hypotenuse. Cosine is still the adjacent side over the hypotenuse. And for this triangle right here, the opposite is AB. That's a B. Over the hypotenuse, which is still AC, this longest one right here across from the right angle, AC. And the cosine is going to be our adjacent side, this one right here, BC, over AC, our hypotenuse. So let's just write this up here. The cosine, the sine, let's start with, is going to be the opposite over the hypotenuse. And our cosine is going to be the adjacent side over the hypotenuse. And this, you'll find, is going to be a thing, hopefully you remember, as long as you shall live. I think it's like one of the number one things that people say that they remember from high school math. And I'll write this where I want to write this. I mean, here it is. So, ka, toa. And I don't typically love to talk about, useful. I don't know your whole life, and I don't know when you're going to use something. But SOHCAHTOA is very helpful, or say useful outside of math and in building and architecture, in construction, in anything you're doing around the house that can be really useful. So we'll come back to this again and again and again. And basically, once we have these three tools, we can choose what's the best tool to use in what different situation. Or, how can we use each of these facts to kind of solve different information given on what we have and what we need. So let's do a few questions, and I want to point something out as we go along. But write each ratio in the lowest terms. So we're looking for sine A. So right here, that's going to be our opposite over our hypotenuse. So opposite angle A is 12 over the hypotenuse. That's always going to be 13. And cosine A is going to be our adjacent side. So this side right here is touching our angle, but it's not the hypotenuse. So that's going to be, adjacent over hypotenuse. So that's going to be 5 over 13 right here, our hypotenuse. Next, if we're looking from reference angle B, sine is going to be our opposite over our hypotenuse, 5 over 13. And our cosine B is going to be our adjacent side now. So it's touching the angle, but it's not the hypotenuse. So 12 over the hypotenuse doesn't change, so still 13. And one thing I want to point out here is that sine, the word sine and cosine, the co in cosine means complement. And no, it's not like nice haircut. If you compliment something, it kind of goes with it. There's two types of compliment. Compliment that's a nice haircut is like that. And this complement with an E means that, that these two angles will add up to 90 degrees. So it's true that sine, 60 is equal to cos 30. And you can check that in your calculator. But those two complement each other. They're always going to add up to 90 in our right triangle. And you'll notice here that so here sine A is equal sine A is equal to cosine B, right there and right there, and that sine B is equal to cosine A. There you go. So for question number 2, this is just a calculator question. Evaluate each trigonometric ratio to 4 decimal places. We're going to use our scientific calculator for this. We're just going to input sine 35, and we get 0.5738, wrong one, 0.5738. And next one, just make sure that you're using the correct ratio. We're going to use cosine this time. Cos, what was it? 12? 0.9784. No, sorry, 9781. So it's just a calculator question. In question 3, determine the measure of each angle to the nearest tenth. Okay, we're looking for an angle, which means we're going to use inverse. So sine A, the inverse of sine A, let's use this here, clear function sine 4 over 5, close our brackets, equals 53 degrees. And cosine 1564, we're going to use the inverse again. 0.1564 equals 81 degrees. Okay, so if we're looking for an angle, whether that's tan, whether that's cos or sine, we're going to use the inverse if we're looking for the angle. And now let's solve some problems. And based on the information that we're looking for, whether that's the opposite side or the adjacent side, we're going to use sine or cosine. And this one, this section 3.2 is only about sine and cosine, but later you'll have to choose between the three based on what we have and what we need. So currently it looks like we have the hypotenuse, we have an angle, and we're looking, we have the adjacent side is what we're after, or sorry, the opposite side. So we're going to use sine because SOH, so we're looking for the sine of 32 is equal to the opposite. That's what we don't know over the hypotenuse. So we're not going to use a cosine for this because that uses tangent or adjacent, and we're not after adjacent. So let's do that. Let's solve. Let's cross multiply and divide. So we are going to, and also I should say that's 11.5, not the hypotenuse. We know the value of that, 11.5. So now we're going to go sine 32 times 11.5 equals x. I just cross multiplied. And let's put that in our calculator. Sine 32 times 11.5, clear. Sine 32 times 11.5 equals 6 point, let's round it up, 6.1. So x equals 6.1. Doesn't say which units it is. And last step, does that make sense? Yeah, I would say that makes sense. Okay, it's, it's shorter than 11.5. Don't know exactly how much shorter, but there you go. Let's try the next one. Looks like we have an angle 50. We want to know the adjacent side, and we know the hypotenuse. So I'm going to use cos adjacent over hypotenuse. So cosine 50 equals, we don't know, over 9. Now we can cross multiply and divide. So cos 50 times 9 equals x. So we did this cross multiplying right here. We went 9 times 50. We're going to divide. We're going to end up that equals x. So let's do it in our calculator. Let's clear cos 50 times 9 equals 5.8, I guess let's say. X equals 5.8. Does that make sense? I would say that does. 5.8 is less than 9. I would say that's a good possibility. That's a reasonable answer. I would say so. Okay, let's do 5. Determine the measure of each indicated angle. So we're going to be using the inverse as the final step. Express your answer to the nearest degree. Okay, wonderful. This one we have reference angle A. We have the opposite and the hypotenuse. So we're going to use sine for that. We have opposite. We have hypotenuse. So the sine of angle A equals opposite, that one right there, 14 over 25. So we can use the inverse operation, clear, function, clear. Sine 15 divided by 25. No, I don't want that. There we go. 34 degrees. So sine of angle A equals 34 degrees. And our next one, here's our reference angle right here, theta. We have the adjacent side and we have the hypotenuse. So we can use cosine for that, adjacent and hypotenuse. So the cosine of angle theta equals adjacent 2.1 over 4.2. So let's see, we need to use inverse again because we're looking for a angle. We've got 2.1 divided by 4.2, and that equals 60. So cos of theta equals 60 degrees. Okay, thank you so much. I'll let you know what questions I'd like you to do.